Alright guys, I got a little update with my solar pulse motor. So basically I just took a steel shaft and tempered the tip with a torch and quenched it so it's hardened nice and sharp. And then I ordered these little like bobbin things. They're threaded and they're perfect for making mini coils other than the fact that the coil size is a little too small for a 3/4 inch magnet. Yeah, I get that, but it's just for now to be nice and neat. I'm trying to find one that is where it can get to about at least 3/4 in diameter. I don't care how small the inner side is because it's just more coil. Because I want to get more resistance on this. But same solar panel that I had before. I put a diode in between the switch to kind of prevent some flyback on the switch. Same capacitor. And then here's another thing that I had to experiment with. I got a little piece of stainless steel to rest the point on because otherwise I should have known that, but the magnet was getting worn in from the tip because it's only nickel plated on the magnet. So yeah, I then did a nickel strip, and then obviously nickel's still kind of soft. So this being hardened steel, it just drove itself right into the nickel after spinning after a while. So now the stainless is the next option. And I know it's not as hard as hardened steel, but it's still harder than nickel. So then I thought I did some research, and this is a thermoelectric generator. This is alumina. This is ceramic alumina, and its hardness is almost as hard as diamond. It's like almost 9 in hardness. But now if you go to use hardened steel on here, then the steel starts wearing out because the hardness is so hard on the plate versus the hardened steel that it wears out the point tip. So obviously you can't have two different hardnesses. One will wear out the other. So if I wanted to use, the strongest material, I would have to use the same material as my shaft, so the rod. And they do make rods, I see, for this, but they are kind of expensive. This material is kind of expensive. So the cheapest route would to be used, like a steel shaft and temper it. So that's where I'm at right now. I do plan on eventually, once I get all the bugs worked out, I'm probably going to start building these and start selling them. So if anyone's interested, once I get to that point, I'm going to start making these things. But yeah, if I wanted to use something like this, I would have to spend more money on a shaft made out of this high quality ceramic, sharpen a point to it. So, obviously, so the harder the material, the less friction there will be, and the longer the point will last on the motor. So if anyone ever want to know what inside of a thermoelectric generator looks like, that's what it is. And then they have all the little tabs of the semiconductors that make the contacts between the copper strips. And then I got the other side, so they're sandwiched between that. I was gonna try and sand all these off, but whatever, I don't know how they embed the copper strip to the ceramic. I'm not really sure how they do that, but it is tough. Like it's just like embedded, it's like fused with the ceramic. I have no idea how they do that. Interesting. It's basically the size of the solar cell. This is 40 millimeter, this is 50 millimeter. I have some polycrystal ones, one's coming. It got delayed due to the massive snowstorm we just got hit by. But this is a 2-volt cell. The polycrystal ones are a 4-volt cell. But I kind of it doesn't really need the high voltage or the higher voltage than 2 volts because it doesn't require much power to run it. But obviously now if I step the voltage up, it might run better in a lower light environment. Although these monocrystalline cells are more efficient in low light conditions, so these might still be better. But my old panel that I had on there obviously is huge. It was I just got off a solar light that we were gonna throw away. That's what started this whole project. It was like a solar light that we were just gonna throw away. I'm like, well, I could make use of the panel, but obviously that's pretty big. I wouldn't want to use something that big anyway. But yeah, this is a polycrystalline. You can tell because it's blue and the monocrystallines are darker. They're practically black. So yeah, that's where I'm at the moment. But it looks a little bit more professionally done now that I got the coils kind of neatly in there, and then they're threaded into the backside. I'd have to cut those off, obviously they're too long, so they're not really resting on the pad anymore. But originally I had the needle attracting to the top side versus the bottom. So now that it's on the bottom, the amount of weight, it does not matter, and it's more stable. So I don't have the issues of it spinning fast. It can run way faster now. I don't have any issues with speed, even though that the rotor isn't really balanced that great. I have two rotors, but this one I both cut them out at the same time, so they're both bad. This is actually the other one. As you can tell, I tried to get it to where I tried mounting it to see if I could clean up the edge to make it look a lot nicer, but it did not turn out very good. It bubbled up on me. I don't know why I did that. I must have just got it a little too hot. And I was trying to move the flame like that, but it just didn't work. I had a diode in between here to maybe see if it could help with the speed, but it actually didn't really help it because the voltage drop was so much. Now, if it was polycrystalline, it might actually work okay because it's a higher voltage, but this is only 2 volts. So if you put a diode between that and the switch, it helps with the back EMF, so it doesn't drag as much, so it does allow it to spin a little faster, but it, being a low voltage, it doesn't really work too good with this setup that I have currently. So yeah, I probably could go down to like a half-inch magnet, a half-inch by quarter-inch thick, but I like having the bigger magnets. It adds a little bit more momentum to the rotor too, instead of just having it like a smaller weight. You'll have less momentum that keep it going. I'm probably going to use aluminum instead of brass. Be a little cheaper. Because I want it to be of high quality, but also affordable. I don't want to make this thing unaffordable for people. I could make this thing amazing, but people probably don't want to buy it at, you know, an $80 unit. That's a little expensive for decoration, I think. But I mean, who knows? Maybe I could make two different models. One's a cheaper version that uses cheaper parts, and a higher quality one for more. That's what I might end up doing. The higher quality would probably be using the best materials, the strongest magnets, and probably try to figure out a transistor driven versus a reed switch, which I'm still trying to figure out. But the problem is, the zero point 0.7 is the minimum threshold to turn on the transistor, and this is only running at like, I can show you. It's only running at like zero point 0.2 volts in low light, and I want it to run in as low as light as possible. So yeah, you can see how little power it's running on. It's not much. Yeah, it's not even 0.2. It's tenth of a volt, under a tenth of a volt. So it's barely using anything. I could try a supercapacitor, but the thing is, then it takes time to charge. So I'm not sure. I'm probably not going to use a supercapacitor. A traditional capacitor is more of a direct connect to the solar cell versus a supercapacitor because it takes time to charge. So if you were to just like, throw it in the sun and give it a spin, it's not going to work right away because it has to sit and charge that capacitor. So I think, yeah, a small electrolytic capacitor is the best option for what this is. And yeah, that's pretty much where I'm at the moment. I think that's about it. Alright, see you later.